let's look at problem 12 for the final review. In this one, I'm going to do the part talking about an opera singer. So it says an opera singer produces a decibel level of 109 dB, your numbers may vary, at a distance of 0.7 meters. It also says that the area of a typical eardrum is about 5 times 10 to the minus 5 square meters. Assume the sound propagates as a spherical wave. Determine the sound intensity and power incident on a typical eardrum at 2 other distances. So we're given information about the decibel level at this first distance of 0.7 meters. And with that information, we can figure out how much power the singer is producing. And once we know that, then we can calculate the intensity at other distances and figure out how much power is delivered to the eardrum at those other distances. So let's start at this initial distance. For me, it's 0.7 meters. For you, it may be a different number. We're given the decibel level. And remember, this is defined as 10 times the log of the intensity at that location divided by this reference intensity, the threshold of human hearing, the quietest intensity that the average human ear can detect. So we're given beta. We know I0, it's 10 to the minus 12 watts per square meter. So let's figure out I. And once we have I, we can then figure out the power that the singer is outputting. So we got to do some algebra. Let's divide both sides by 10. And then the way logs work is you raise both sides of the equation to the 10 power, and that gets rid of the log. So we can say 10 to the beta over 10 equals I divided by I naught. And finally, we multiply both sides by I naught. And we can calculate the intensity at this initial distance of 0.7 meters. So let me do that. This is 10 to the minus 12 watts per square meter times 10 to the 109 over 10, or 10.9 power. You're going to have different numbers. Let's see what this is. 10 to the minus, I'm using my calculator, you can't see. 10 to the minus 12 times 10 to the 10.9. Okay, it is 0.07943 watts per square meter. Cool. So the power that the singer is outputting, I'll label this P S for the power that the singer is producing, is the intensity times the area. And here we're concerned with the area of a sphere. So if this is the singer and they're singing, and that singing is going out in all directions, the power of their singing is spread out over the surface of a sphere of surface area 4 pi r squared. So we do the intensity, 0.7943 watts per square meter times 4 pi 0.7 meters squared. And the power that the singer is producing is a little less than half a watt, 0.4891 watts. So let's just keep this in mind. We'll need that number. That is singer's power output. So you can think of that singer as being like a loudspeaker, and that loudspeaker is generating half a watt of singing power, or 0.4891 watts of singing power. All right, now as we go farther out, say 6 meters, the intensity is going to be the singer's power output divided by the area at that location. So that's the singer's power output over 4 pi r squared. Now we're looking at like a bigger circle, a bigger sphere, a much bigger sphere in fact, 6 meters instead of 0.7 meters. So we expect that this intensity is going to be less because it's the same amount of power, but the surface area is a lot greater when you go farther away. That's why sound gets quieter when you're farther away. So let's calculate what this number is. We've got 0.4891 watts over 4 pi times 6 meters squared. Okay, and just like the problem tells us there, it is 0.00108 watts per square meter. Okay, and the next thing we want is the power that reaches the eardrum. So we already figured out how much power the singer is outputting, but some distance away, there's a listener and there's their ear, listener with big ears. So how much of this power actually reaches their eardrum? Well, the eardrum's pretty small, so the power that reaches the eardrum, I'll write power ear, is that intensity times the area of the ear. And we use the intensity we just found. times this area for the eardrum. 5 times 10 to the minus 5 square meters. And that equals, oops, 5.41 times 10 to the minus 8 watts, like we were told here. All right, and you can repeat the same process for part B, just use 19 meters instead of 6 meters when you calculate the intensity. And then use that new intensity again with the area of the eardrum. So the moral of this problem is that when you have a sound source, like someone singing or a loudspeaker, they are outputting a certain amount of power. That power is spread out over possibly a spherical surface. You can calculate the intensity at any distance from the source by dividing the power by the surface area of that sphere. And then once you know the intensity, you can calculate how much power reaches a certain amount of area. And in this case, the area we're interested in is the area of the eardrum. That's the power that hits the listener's ear.